Hey there, I'm a tutor with Tutorial Haven, and in the next few minutes, we're going to crack the code on one of the most intimidating topics in all of chemistry, naming organic compounds. Let's jump right in. So you're in an exam, you flip the page, and you see a name like this. Does your brain just kind of short circuit? I get it, it looks like a secret language, but I promise you, it's not. It's actually a super logical system, and we're about to break it all down. In this explainer, I'm going to show you the simple rules behind these names so you can read and write them with total confidence. Seriously, by the end of this, that crazy-looking name from before, it's going to seem perfectly straightforward. Okay, but why? Why do we even need this whole complicated-looking system? Well, it's all about creating a universal language for chemists everywhere. And that language has a name, IUPAC. Think about it. There are millions and millions of organic compounds. We absolutely need one single, clear name for each one. This makes sure a chemist in Tokyo and a chemist in Toronto are talking about the exact same molecule. It's what prevents huge, costly, and sometimes even dangerous mistakes in labs and in medicine. The real key to cracking this code is to figure out what family a molecule belongs to. And in the world of chemistry, these families are called functional groups. I want you to think of a functional group as the molecule's personality. It's the active part, the part that actually does stuff and dictates how the molecule is going to react. If you can spot the functional group, you're already halfway to predicting its behavior. So here are some of the main players you're going to see all the time. Each one has a special ending or suffix. Alcohols get OL, ketones get ON. You get the idea. But, and this is super important, notice they also have prefix names, like hydroxy for an alcohol. This becomes a huge deal when you have more than one functional group in a molecule, which we'll get to in just a sec. All right, let's get to the good stuff. How do we actually build one of these names from the ground up? It really just comes down to a simple 4-step recipe. These are your 4 golden rules, okay? First, find the backbone, the longest continuous chain of carbons you can find. Then you spot anything branching off of it. Third, you give that main chain address numbers, and you want to give your branches the lowest possible numbers. And finally, you just put all the pieces together in the right order. Let's give it a shot. Take a look at this molecule here. We just count the carbons in the longest chain. 1, 2, 3. Okay, the parent name for 3 carbons is prop, and since all the bonds are single bonds, it's an alkane, so we add the ane ending. Boom, propane. See? Simple. Okay, now let's level up just a little. Here, the longest chain is still 3 carbons, so our parent name is still propan. But now, see that little branch sticking off? That's a 1-carbon group, and we call that a methyl group. Now we number the main chain to give that branch the lowest possible number, which is 2. So we put it all together, 2-methylpropane. It's just a system. Right, that works perfectly for simple stuff. But you know, chemistry, it always likes to throw us a curveball, right? So what happens when a molecule has more than one important feature? For example, what if a molecule has an alcohol group and a carboxylic acid group? Which one gets to be the family name? You know, the suffix that goes at the very end of the name? We need a tiebreaker. And here's the solution, the IUPAC priority list. Honestly, just think of it like a pecking order. The group with the highest rank gets the crown, that's the suffix. Every other group gets demoted and has to use its prefix name. And the most important rule to remember is this: 1 name, 1 suffix. That's it. So let's go all the way back to that first scary molecule. Remember? It has 2 functional groups, a carboxylic acid and an alcohol. We check our priority list and bam, carboxylic acid is the king. It outranks the alcohol. That means the name must end in oic acid, no question. So what happens to the poor alcohol group? It gets demoted to its prefix form, hydroxy. Then we just number the chain, starting from the king, which puts the hydroxy group on carbon number 3. Put it all together, 3-hydroxybutanoic acid. It's not magic, it's just following the rules. Okay, let's bring it all home. When you're in an exam, you need to be quick and you need to be right. So let's boil all of this down to the absolute must-know takeaways. Now here's a super common trap on exams, getting mixed up between the official IUPAC names and common everyday names. You've definitely heard of acetic acid, that's just vinegar. Or acetone, right? Those are common names. But for your exam, unless they specifically tell you otherwise, you always use the systematic IUPAC name. So ethanoic acid, propanone. It proves you know this system. So here it is. This is your exam cheat sheet. Just 3 simple steps. 1. Find the parent chain that includes the boss functional group. 2. Identify that boss, the highest priority group, and give it the suffix. And 3. Treat everything else as a simple prefix. If you can do these 3 things, you can name almost any molecule they can throw at you.
And I want to leave you with this final thought. Naming these things isn't just about giving them a label. That name tells you everything you need to know about the molecule's structure. And if you know the structure, you can start to predict its function. So the real question is, now that you can identify that alcohol or that ketone from its name, are you ready to predict how it will behave in a chemical reaction?
Because that's the next step on your chemistry journey. This lesson was brought to you by Tutorial Haven, where we help you get ready for exactly those kinds of questions. Happy studying!